We're asked to show that the function f of x, which equals the absolute value of x, has no derivative at x sub naught equals 0, at initial value of x equals 0, or at the value x equals 0, yet it is continuous. So let's go ahead and take the function. Let me go ahead and grab a straight. Okay, so what I'm going to do is I'm going to graph out the function absolute value of x. So it looks something like this. And where we're interested in looking at is this value right here. Okay. Now, clearly the function's continuous. Okay. Let me show you why the function's continuous. If, for example, if I take let's just write it like this, the limit as x approaches 0 of f of x should be equal to f at 0 if it's continuous. So let's look at this. Well, the limit is x approaches 0 of f of x. Well, f of x is equal to x when x is greater than or equal to 0, and it's equal to negative x when x is strictly less than 0. So let's take a look. There's two situations. There's the limit as x approaches 0 from the left. That idea is that as we come in from the left side, what are the function values approaching? It's clear that they're approaching 0, right? So the limit as x approaches 0, since these guys are all negative, it's like asking what is the limit of this guy, because we don't care about this right here. We only care about this because we're coming in from the left side. And so as x goes towards 0 from the left side, it is negative 0, which is just 0. Now as we come in from the right side, as I come in this way, the question is, what is the function doing? Well, the function is also approaching 0. And so we would use, since we're only looking at x values over here that are positive, we get to use this piece. But again, this is a continuous function, and evaluating it at 0 gives us 0. So the limit, the overall limit as x approaches 0 of f of x, or the absolute value of x, those limits both equal 0. And also f at 0 is the absolute value of 0, which is 0. So the limit is equal to the function at that value, which implies continuity. However, what about the derivative? Okay, so what we've shown is this back part. We've shown that that function, the absolute value, is continuous at 0. So it is continuous here. What about the derivative? We're going to show that the derivative doesn't exist. So the derivative, if you remember, f prime is going to be equal to the limit as delta x goes to 0 of f at x plus delta x minus f of x over delta x. Now the x value that we're considering is x naught, okay, right? The x value, x naught, is 0. So this becomes 0, this becomes 0. Okay. So this is actually at a specific point. So when I put 0 in and 0 in here, that is like putting 0 in here. It's exactly the same. So f prime at 0 is equal to the limit of this ugly mess. And this is not bad. Watch this. So this is equal to the absolute value of 0 plus delta x minus the absolute value of 0 over delta x. This is equal to, this is 0, this is just delta x, so absolute value of delta x over delta x. Now here's the problem. When x is negative, then the absolute value of x is equal to negative x. That right there is by the definition of absolute value. So this right here, when x is less than 0, basically when we're coming in over, whoops, I did not mean to do that. When we're coming in over here on this side, what's the slope of the tangent line? Well, it's going to be -1, and watch, it will be. This right here, the change in x, the absolute value of delta x is going to be equal to negative delta x. Okay. So this will be equal to the limits as delta x goes to 0 of the value -1, which is -1. Okay. However, when x is greater than or equal to 0, the absolute value of x will be equal to x, which means the absolute value of delta x as delta x, because remember, we're coming in, it's not so much that that we're coming in from the left side or the right side, and it is, but the delta x value would be negative over here, positive over here. It's really a direction issue, okay? So I'm comparing it to the x's, but it's the same thing, even though understandably I know they're different. Okay, so this is going to be just equal to delta x. Okay, but again, if you thought about this, this guy would be equal to +1. So what we're showing here is that as we come in from this direction, right? So if I take any 2 points, if I grab a point here and a point over here, and then I take this point and I push it towards that point, the tangent line is going to be -1. However, if I take a point here and a point here and I push these guys this way, it's going to be +1. So the slope of the tangent line from this direction would be -1, this would be +1, and they don't agree with one another. Okay, because the overall limit, this guy right here, this overall limit from as delta x is negative, then I get -1. If delta x is positive, then I get +1. And see how they're different. So clearly the derivative can't exist at that value. Okay, but it is still continuous.